Hello again.
Hello, everyone. We're back. I guess we can skip the introduction. You have seen me and Hossein before. This section will be about the LMs and the generative AI tools. Please let me shortly overview the generative AI services available in Aalto. So we have a public service as a web service. It's similar as ChatGPT, but it's under agreement between Aalto and the company. We call it Aalto GPT or Aalto AI Assistant. It's similar as ChatGPT and based on the same models. Secondly, you can use some remote APIs to run models, and Aalto also has institutional agreement with Azure OpenAI API, so you can request that. It has a better data security. In addition to that, we have hosted some local models entirely on Aalto's infrastructure. Those APIs are based on open source models, so they have very good data privacy. So basically, you can use them and maybe request for different models. This job is in developing. And of course, if you want to run models locally on your computer or on a cluster to get higher performance, it's also good. And actually, that will be our main focus today. But usually your computer doesn't have enough resource. So Triton or the other cluster you're working on will be a good option. But in addition to these general AI tools, we also have a dedicated tool for speech to text. Hossein knows better about this.
Yeah, but just to add something about the APIs that is provided by ITS, if I'm not mistaken, you can use it with confidential data as well, but it has this cost structure and you have to go and like fill a form and everything. But if you host your model locally, you don't have to be worried about the cost and everything, all except for the GPU time that you are getting for the cluster. So yeah, it depends on the in the project. But we have also another service called speech to text. It's based on the OpenAI Whisper, and it's like very good for transcribing your videos or audios or interviews that you have. We would show like how to run it on, or maybe we don't have time, I don't know. But if you go to the docs and click on the link, there is a very good documentation that you can follow, both on demand on the web service and also on the terminal if you prefer that. All of the processing is done on Triton, so you can process confidential data as well. And it supports multiple languages. It's at the moment very fast because it utilizes on the GPUs. And yeah, I guess that's it. Or is
Okay.
there anything else that you want to add?
I think that's it. Let's go to our main focus today,
Yeah.
which is running LLMs on the cluster. So we know that LM models, they are very big and they usually need quite a lot of disk space to store the models. So we pre-downloaded the popular models on Triton. So you can access them and you can use them. It's in a shared folder, so it won't occupy your own disk space. But there's some tricks to use the models. We will talk about the coding part later. But firstly, maybe you want to know which models are available. So simply run this command on Triton. Of course, you will see all the models listed there. You can request more models if you need, and we will also be keeping our eyes on the latest models and download them for you. The most common way to use the models is by using Transformers Python library. It's developed by Hugging Face, and it also provides a lot of tools and models, of course, to use. It has a very good interfaces to use the models. We will demonstrate some examples later. But after you know that where to find the model, the next thing to consider is to how much resources to request to use the model. You have just listened to the wonderful talk from Simon and Hossein about GPU computing. So when it comes to LLMs, GPU is well, most of the time needed. So you need to request the GPUs. The thing is, which what kind of GPUs to request? That depends on the model, which model you are using. And meanwhile, you need to request some number of CPUs and system memories. You have just listened to this, that the system memory is something separate from the GPU memory. Let's first talk a bit about the GPU memory. So when you request a GPU, you get the whole GPU, so all the memory belongs to you, but different GPUs have different amount of memory. On Triton, we can use the S-infer. I think Simon also showed that to get a list of partitions available. So partition names can reflect the GPU tab. For example, GPU V100 with 32 gigabytes memory. And there are also some other newer GPUs like A100 or H100 and H200. But the thing is, how much memory do you need? It depends on the model size. Let's go. We have a table here to as a reference that usually when the model you find a model on Hugging Face, there will be a model card. The model card will tell you how many parameters the model has, and also from the model the model name, you can also know the number of parameters. For example, it's a Mistral 7 billion model, then it has 7 billion parameters. But it depends on the data type used by the model. It could be like 28 gigabytes or 14 gigabytes, or if you quantize the model, then it will be even like half the memory. So this table can be roughly telling you that how much GPU memory you need, and then which kind of GPU you can request. But there's some other tricky things here because like AI is developing very fast. Some models, they use different operators, and some operators or model layers may need a different GPU computing capacity. So it's a bit tricky that maybe the model can fit in the GPU, but it doesn't. The GPU doesn't support the model or the software you use to run the model. So you may also face this kind of errors. Don't be don't be very worried. You can come to us. We can help you to do the troubleshooting, and you can also try out. Generally speaking, try out newer GPUs. So that's about the GPU memory. Let's go back to this again. And there's the system memory. The system memory, well, like Simon mentioned before, it depends on how your program was written and how the data will be loaded. So usually we will request a bit more memory, system memory than GPU memory. But for example, here, the GPU memory is 32 gigabytes. I put 80 gigabytes here, but it's probably a bit too much, I would say. But roughly speaking, the system memory is less expensive. So I would use a slightly higher number. For example, maybe 40 gigabytes is enough here. Yeah. And then the CPUs, number of CPUs. Sometimes you need multiple CPUs to run the models. Some framework can use multi-processes to like do some data pre-processing, or even some intermediate steps may need more CPUs. So in general, I would put a few more CPUs here, and again, it's less expensive than GPUs. So what do you think, Jose? Do you have anything to add here?
Um, I was trying to answer a question, but
Uh,
no, I think it's fine. But the thing that you were mentioning about the architecture of the model is
mm,
also an important thing. And again, if you don't know what is happening, I guess you don't have to worry about. But sometimes some part of the model or like some part of the calculation needs a specific kind of architecture, like flash attention, that is like very popular nowadays. But if you run it on a normal GPU that doesn't support the flash attention, it would just raise an error. So it's like very likely, especially at the beginning, when you're working with these huge models, to care to face a lot of issues, and then uh, don't get worried. Come and ask us, and we will try to help you, or ask ChatGPT in that case. But we prefer human interaction.
yes. Okay. Yeah, I mentioned that we have downloaded a lot of models for you and put them in a shared folder. The thing is, Hugging Face Transformers doesn't look for the models by default. There is an environment variable called HF home. By default, it's pointing to your home folder. As you have learned on the first day, I guess, your home folder is kind of small. It has only 20 gigabytes disk space. So so what you should do essentially is to change the home, the Hugging Face home to the shared folder we have. But again, as you have learned before, on Triton, or I would say most clusters, uh, uh, a lot of softwares and tools will be managed by modules. So here we also use a module to manage the access to the models. So you need to module load the model Hugging Face. What this does is basically setting the Hugging Face home to the correct location, the correct directory, which is this one here. Um, yeah, and by doing this, transformers will know where to find the models. But after that, you need to have a proper conda environment to use the models. We have created a model, sorry, we have created a conda environment, which is called SciComp LLM-inf. This is managed by us. It has most of the popular frameworks like transformers, like Llama CPP and stuff like that. But if you need your own ones, you can make a customized conda inf by using the knowledge you learned from yesterday, I think. But anyway, for this demo, we can use this one, and like most of the times, this one would work, I would say. So that's the Python environment. But after that, we needed to do something else to let transformer to find the to use the local model instead of downloading models from Hugging Face. So we needed to set up two environment variables. Here is transformers offline, kind of set it to true, and then export another one. It's also for transformers to load the local models, and then run your Python script. We will show the example later. This is I will skip this Python script. We will see it in the demo. Mm, I think that's all from here. We can start the demo now.
Maybe we can show
Yeah.
a real example.
Sorry.
Yeah, we can show a real example. It can be a bit overwhelming to hear all of this at in a 30-minute session, but once you understand a bit of it and then get your hands dirty, you would don't worry, you will get it. It's but at the beginning it can be really overwhelming with all of the environments and different parameters that you have to set.
Yeah. Okay, let me go to the. I'll use the on-demand Jupyter Notebook to do the demo. This is my work directory. I haven't downloaded the examples. I will go to the repo. Okay.
The LLM examples report, yeah.
Yes, it's in the note.
Mhm.
Okay. See. Okay. You can see we have a few different examples here. Today we will focus on the Hugging Face models. We also have models for VLM and also a little small example for like chat with your PDF. It's a kind of AI application example, but we will focus to Hugging Face. Yeah, so basically we have a minimal example here. I have the submit script. So this is the one. This is a batch script you have seen from the previous days. So basically I have the time here and the number of CPUs and the memory. Okay, I have 40 gigabytes here. It's more reasonable. I request 1 GPU. Of course, you can request 2 GPUs if the model is large and couldn't fit in 1 GPU. But that's a little bit advanced. Maybe we can look at that later. If you need help, come to our help session. And then the partition, I will use this V100. I would say this is a bit old GPU, but the model I'm going to run is also not a very new one. So as I mentioned before, load the necessary modules and run the script. I will submit the job firstly because it will take a while.
Yes. But what does it do, the script? Can you also show the script and we can see?
The Python script.
Yeah.
I will show that later after I submit the job. Okay, now it's submitted and let's check out if it can start immediately. Okay, it's pending. Let's go to the script. So this is the script I submitted by using the shell script. It's a example to use the model. This is the model I'm using here. Hugging Face provides basically two different ways to run the model. The first one is a little bit complex. You can see it has multiple steps. Firstly, you need to load the model, like initialize the model, specify the data type. I use Aalto here. By using this, it will automatically choose the best data type or the default data type when the model was released. And I also did some memory usage reduction by quantization. So I will load the model with 8-bit instead of float 32 or float 16. And I set the device map to auto to let it automatically find the GPUs available. Maybe I shouldn't go to that detailed stuff. Yeah, we have the tokenizer, and the tokenizer will be initialized under the messages you want to pass to the model, and then use the tokenizer to do some pre-processing for the text, like apply some chat template. but again, we won't go to the details. This is necessary for some models. And then the inputs after the pre-processing, the inputs will be passed to the model. The model has a generate method, and then we will see the generated stuff. But this is a slightly complex procedure to use Hugging Face models. There's a higher level help API from transformers or from Hugging Face. It's easier. But before that, maybe let's go back to the terminal to see if it's running. Okay, it's done, I think. Okay, it's done. Actually, I want to show you the GPU usage. Maybe I should submit it again.
But we can also like look at the Ceph data as well.
Yeah, of course. And let me see if it's still running. Okay, it's pending. Anyway, let's go back to this one. So an easier way to use transformers is by using the pipeline API provided by Hugging Face. You don't need to specify the tokenizers and initialize the model separately. You just put all the stuff to the pipeline, the name of the model, the task, the name of the model, and the device, the GPU, and some other parameters, some generation parameters or model arguments, and all the configuration stuff here. Then the message, then it's.
Sorry to interrupt. The job is running, so if you want to show the.
Yes, let's see. It's quite. I will. I hope it won't be stop. Okay, now we can see the usage of GPU. So I gave it 32 gigabytes memory GPU, but it used only half of the memory. GPU utilization is also like lower than 50%. Well, this is something you can see yearly. Okay, now I think the calculation has started. The usage of the memory is increasing to 24. Okay. Yeah, so basically you can have a look at the GPU memory usage and the computation usage in real time. But as Jose mentioned that after the job is done, we have the other tools to show the resource usage. Okay, now maybe let's have a look at the output. We have two. The first one. Yeah, the output, well, it's not something very exciting. I just give it a message, and it will apply a chat template, kind of give the model some reminders. Okay, this is the starting point of the prompt. This is the end, and this is the starting point of your message. Sorry. So firstly is the system prompt, like your helpful assistant thing, and then it's the starting point of your message, your question, and then it will also add the starting point for the assistant, kind of telling it now it's your turn to continue the generation to answer the questions. Yeah, we can see. Yeah, then the pipeline. By using the pipeline, it's we kind of skip the intermediate steps and get the response. It also has the by default it will give you the prompts and the answers. You can do post processing for this. Okay. Do we have any questions?
I was trying to answer the questions, and we have a user who faced an error with the CUDA, I guess, but I'm not sure.
Okay.
And yeah, but I just want to ask a question. When we're like looking at the utilization was uh around 20 or 30%. Uh, how can we try to increase that? Or why is the utilization low, I would say?
Uh, I think the utilization is low, mainly telling us that the GPU is waiting for CPU doing stuff, or like sometimes it's the input to output things going on, and the GPU is waiting for that. But in our case, I think it's mainly CPU waiting for GPU, GPU waiting for CPU to do stuff. But our example is quite small. We don't have a very large input data, and also we requested. I think we do some quantization of the model. Yes, we did. We used this to do some quantization. It will also make the computation lower and the usage lower. But if you are running something very big, you would definitely need to optimize the usage of GPUs. But don't worry about that. It's a bit complex or tricky sometimes. So uh, don't don't hesitate to talk to us.
Yeah. What essentially it means that the utilize like low utilization, it means that your GPU can do much more like computation. And because like we are only answering like a simple questions here in the um, in this example, it means there are not enough data or not enough computation for the GPU to be done. So if you have low utilization, one of the things that you can try is like feed it more data or more complex data to a more complex um, model in this case. And as you mentioned, because the model is not complex, it's only has 8 bits of the parameter of each parameter. It means every calculation is like done very fast. So yeah, there are like some techniques to make that GPU more useful or like make it more work. But yeah, it can be very complicated. So come and ask us, and we will try to help you with that.
Yes. Uh,
Yeah. So anything else that you want to add here?
I don't have too much from my side. I mean, we only give a very simple demo. There are too many the other details.
Yeah.
Um, yeah, unfortunately, we don't have enough time for the exercise today, but we will be there.
So what we would recommend is to try to run the LLM example by yourself. I would look at the example again and see if we can find the error that the user was facing, and we would reply in the notes. But try to rerun the example and see if you are facing an error, and if you can do that. Of course, you can do like much more. You can like request multiple GPUs with like larger amount of like larger model, so to divide the model and everything, but it's more complicated and it doesn't fit in that 30-minute session. So yeah, if you want to learn more, or if you have any questions, come and ask us. And yeah, I think it was good and we are right on time. So what is next? I guess we have a, no, we don't have a short break. So we have the wrap up and some